Okay, I mentioned alkanes are never considered a functional group, right? Just with the single bonds. But we do consider alkenes, which are any molecule with double bonds, is an alkene. And any molecule with a triple bond, carbons, is an alkyne. Those are considered functional groups simply because they make this part of the molecule reactive. Whereas it takes a lot more effort to get an alkane to have a reactive carbon. You got to do things like turn it into a carbocation or a carboanion to get it to react. And oftentimes that it also involves an alkene or an alkyne getting in the mix to do things like that. So we have to still go back and determine the root of the compound. So you look and you figure the longest carbon chain. So for our first example, which is kind of, it's down in the bottom. You can probably see it better in the back. The longest chain there is going to be 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, 6. The longest chain is the one which includes the double bond. Notice that we don't go to the 1, 2, 3, 4, 5, 6 carbon length, which would be across the bottom. In this case, the parent chain is the one that includes the double bond. So the root for the first one would be pentene, derived from the pentane, 5 carbons pentane. We just changed the ending to pentene. So the first one is fairly simple. The second one might give you trouble because how do you name that one? Remember, when you have a cyclo of any kind in your molecule, you take the number of carbons in the cyclo separate from those in the straight chain or the branched part of the chain. And then you compare those two lengths. So in this case, if we were to compare, if there was no double bond there, then we would say there are 4 carbons there. And then what's left over? 1, 2, 3, 4, 5. So the straight chain would win. And the cyclo would be added onto the name. But in this case, since there's a double bond in the cyclo part of the name, the cyclobutane, now we've got a cyclobutene. So the double bonds and the triple bonds have an influence on what the parent chain is. You have to include the double bonds and triple bonds in the parent chain. So even though there are only 4 carbons in that cycle, it wins as the parent. So our root there is cyclobutene. And then the last one, we have a triple bond, 1, 2, 3, 4, 5, 6 carbons versus 1, 2, 3, 4, 5. If you took this branch over here, that would only be 5 carbons, still including the triple bond. But if you go up here like that, now you've got more carbons. So that both choices include the triple bond. So we do take into account the longest chain in that case. So it'd be 1, 2, 3, 4, 5, 6. So it'd be hexene, hexine.
Can you say that one more time?
1, 2, 3, 4, 5, 6 versus 1, 2, 3, 4, 5. Both of our choices include the triple bond. So once we've got the triple bond covered, we look for the longest carbon chain.
So you count it twice.
Well, you're counting one end of the triple bond, one end of the other one.
Yeah, the triple bond's in both choices, right? We have to make a choice. And in this case, both of these choices include the triple bond. So then the tiebreaker is the longest carbon chain. Now that we've got this covered by either one, then we say this is the longest carbon chain, so that's the one it's included in. So it starts off as hexane, triple bond means YNE, hexane. So the hexine would be the parent in this case.
Can we go back to the cyclobutene? I don't understand. Like, I understand like the double bond has to be the parent chain,
Yes,
but is that just it?
yeah,
Okay.
right. If you don't have any other choices, then that's final. In this case, we had two choices because this was included in both of them. Right, that's included in both. So we had two choices here, and the longer one was the best. But when you've got a cycle with the double bond in this case, then that wins hands down.
Okay.
There are no other choices. Okay, now that we've got the root or the parent chain fixed, how do we identify it? You number your compound such a way to give you the lowest value for the double bond or the triple bond. So in the first one, instead of numbering it from the chlorine side, which would give us 1, 2, 3 for the ene, we number it from the left-hand side, that would give us a 2 ene. Okay, and the first carbon that you encounter for the double bond in this case is the number that's placed that identifies where the double bond is located. So if we have this, let's see, 5 carbons. Starts up, yeah. 1, 2, 3, 4, 5. And then this double bond is on that location. And this one is forward. Okay, so we wouldn't number it from this side, 1, 2, 3. That would be, all right, what's the parent first? 1, 2, include that, 1, 2, 3, 4, 5. So that would be pentene. And the convention is the number goes in here before the ene. So it's 1, 2. Pen2ene. Okay, they don't show us that on this slide, but that's where we're headed. Rather than 1, 2, 3, pen3e, it's pen2e. And then we say, all right, in that case, that makes this 5 chloro pen2e. Okay, is that on the next slide? No. They're going to wait and solve a more difficult one. I think we ought to solve the easy ones first. Okay. How about the next one? We got 1, 2, 3, 4, 5, 6. 1, 3, 4, 5, 6 carbons. And then we got a branch here. And then we got a 1 here.
Now, why are we not starting from the other side so we would encounter that?
1, 2, 3. Yeah, either side would give you a 3-ene, wouldn't it?
Oh,
From the left to give you a 3-ene, from the right gives you a 3-ene.
all right, that makes sense.
But if we start from the right, that gives you the methyl branch, the lower number.
Right.
Yeah. So this would be hex. Hex 3-ene. And this would be our 2 methyl. Hex 3. That gives us the lowest number. Okay. Let's see. We've got 7 ring. A cycloheptane is where we start. Let's see. If I can draw this 7, 2, 1, 2, 3, 4, 5, 6, 7, 7. Okay. And we've got double bond on that one. And we have a nitro on this one. And we have a nitro on this one. Okay. So this is going to be our beginning is cycloheptane. Cyclo. But it's not heptane, it's heptene. So we need a place in here for the numbering. Heptene. We got to decide, how do we number this one? We want to number this one so that we make these nitro groups the smallest possible. So if we went from this side and we went that way, that'd be 1, 2, 3, 4, 5. Went this way, it'd be 1, 2, 3, 4. So we want to go clockwise to give us a 1 and a 4. So it'd be 1, 4, nitro. Nitro or nitroso? Nitro. I think it's nitro. Then cyclo 1, 2, 7. We still want to start on right here, not right here. Because if we started here, that would give us a larger number set going this direction, or either direction. It would give us larger numbers for these values. So we want to start here.
If there wasn't something attached there, would we usually want to start at the double bond?
Yeah, well, if there's
Like,
nothing here
yeah.
and nothing there, actually, if there's nothing there, that doesn't matter. You don't even have to say hep1E, right? Because it doesn't matter where you start. Right. So to be non-redundant, we just leave that out. It's cycloheptene. That's it.
That's all that structure is. Now, what is the 5-fluoropen-2E? Is that the middle structure?
Yeah.
Oh, yeah, sorry.
And where am I getting 5-fluoropen-2E from? Oh, okay, that's the middle one.
That one or this one? This one?
Oh, okay, got it.
Right, they're separate.
So this bottom one would be 1, 4 nitro.
Actually, it's just be heptene. Yeah, 1,4-nitrocycloheptene. Because it's only got one. Yeah, in a cyclic compound, you start with the double bond. The trick is, how do you start? This just means that the first nitro is attached to the carbon that begins the double bond. And then the fourth one tells you which direction to go, right? We could take it and flip this molecule over, right? And then instead of going this direction, we go the other direction to give us the smallest numbers, right? It's good to start thinking in those terms, like just because we draw it that way doesn't mean that it has to be that way in the real universe, right? It can rotate, it can flip around. This is just drawn, this is convenience. Or homework peculiarities. Okay.
So is that the full thing?
Oh.
Is 1,4-nitrocycloheptene?
Yes.
Okay.
Unless they prove me wrong later. But that's my guess and I'm sticking with it. What a difference. What a difference a little WD-40 makes. Are you done?
Yeah, I guess I'm just a little confused as to like when will we know when we need to do the like dash ENE, like instead of putting it together.
Oh. Well, definitely if there are two of them. Because you can have another double bond as a possibility. If you have two of them in there, then you do have to give them numbering order. but we haven't got there yet. If it's in a straight chain, then it's important that you do, like if we spread this chain out, then it depends on where we break it. If we broke it here, it'd be one way. If we broke it here, it'd be a different way. So if it were a straight chain, then it wouldn't matter where we start. If this were on the end of the molecule, I haven't, when you have one double bond at the end of the molecule, I've never seen a 1E. You just assume. Right. Unless they prove me wrong. Right. Let's go ahead and see if they do. Okay. Okay. Okay, here's the rule, right? And number one, for a cycloalkene or alkyne, the locator number is typically not included because it's understood to be 1. That's where you start. You always start at the 1 position is where your double bond is or your triple bond is. Could we put a triple bond there? If we didn't have that one. Yeah, that would work. You could do that. It'd be difficult, but it could be done. Now I'm thinking in terms of bond strain, because if you got 2 carbons and 3 bonds, right? Where are those 3 bonds coming from? Well, this is a sigma bond. Remember general chemistry. These are pi bonds. Those pi bonds have to be sideways overlapped. So how are they overlapped? Well, they got an unused pi here and an unused pi there. Those overlap. And then you got 2 in and out of the board. They overlap. And what they do is they tend to fix those carbons in a straight chain. So when you try to bend them to get to this sigma to the next, this sigma gets to the next carbon, it's a strain on the molecule, right? So it would be difficult to put a triple bond in there. I'm sure somebody's trying, but not very stable. Okay, so it's understood to be number 1 when you start in a cycloalkane, alkene or alkyne. All right, let's look at this one. Let me draw it up on the board. 1, 2, 3, 4, 5, 6. 2, 3, 4, 5, 6. And then we have a branch off of here. A branch over here, double. And there. Then we have 2 chlorines here. And that's it. Okay. What's the parent chain here? It's got to include that. So we could either go 1, 2, 3, 4, 5. We could go 1, 2, 3, 4, 5. That's 5. Or we could go 1, 2, 3, 4, 5, 6. That. The reason I started up here is to be sure I got that one in there. If I started over here, then I'd have to go that way or here that way. But if I go this way, then I've already been that way with 5. Go this way. Makes 1, 2, 3, 4, 5, 6. So this is the parent chain right there. Okay. So that's 6. That's hex something ene. And what do we have over here? Well, we have, let's see. That's a challenge. Let's do these first. So we have dichloro. Dichloro, which would be, we start here 1, 2, 3, 4. So it's 4 dichloro if we count that way. We count this way, 1, 2, 3. but it's 4E. We count this way, it's 1, 2E. That would be the winner. Smaller number for the ene. Yeah, 1, 2, 3, 4. Then we have 4 dichloro hex 2ene. But we need this one also. Chloro is probably going to be first. What group is this? That's a carbon and 2 methyl groups. So in this case, we say at the 1, 2, 3 position.
Dominant.
Yeah, let me move this out. Hex 2E. We've got to say at the 3 position, we get this group right here, which is a carbon, carbon, carbon. That's a propyl group. Okay. So how is the propyl group attached? It's attached on the 2 carbon. That's 2 propyl.
Wait, where's the 2 carbon?
This is 1, 2, 3.
Oh, so we're counting a brand new chain.
Yes, that's why I put it in parentheses. This, whatever is in here, is attached at the 3rd carbon on this parent. Right, this is 3. 1, 2, 3, 4, 5, 6. But within this side branch, that's a propyl group, and it's attached by its number 2 carbon. Okay, I think that's the way it goes. Let's see if they agree with me. What's the longest carbon chain? All right, we got that one. Which end of the carbon should numbering begin? Allow the CCC group to be encountered earliest. Yes. Okay, we did that. All right, hex 2ene. Which locator number for the CC atom should be included in the IUPAC name? Well, it's 2. All right. We're coming from this one. The smallest number is the one we start. We don't put a 3 in there because we encounter the 2 first. All right. So there's the first decision. We've got a hex 2ene. Let's see. And then we've got all right. Now they're saying methyl ethyl substituent. All right. So here's what they're saying. This is an ethyl, and there's a methyl attached to it on the number 1 carbon. So they're saying rather than 2 propyl, they're saying 1 methyl. This 1, they're saying this is 1 and that's 2. This is our methyl group attached at the 1 on the ethyl group.
Where's the ethyl group?
The ethyl group is here. And this is the methyl group attached at the number 1 ethyl. So they exercise their veto power. And my assumption is wrong.
And is there any right, is there more than one correct answer ever, or is it always just one right answer?
It's, well, the ideal, according to IUPAC, is there's only one way to write a correct systematic name. The reason for that is you don't want more than one structure being assigned to a name. You can't write a name and get 2 structures out of it. Or you can't take a structure and write it 2, 3, 4 different ways. That leads to confusion. You want an unambiguous name and a non-redundant name. So that's what they say is correct. I think the important takeaway here is finding out what this is and then recognizing that this is a subgroup that has to be named. I just named it wrong. All right, so we got some more examples. Yeah, we got 3 examples there at the bottom. I think the first one has 2 carbon-carbon double bonds incorporated. So in that case, 1, 2, 3, 4, 5. Seven. This one's a double bond. And this one's a double bond. There. Yep. When you're trying to decide what's the longest chain here, if we went 1, 2, 3, 4, 5, that would only include one of these. We need to include both of them. So we go 1, 2, 3, 4, 5 to include both of those enes. That makes it a diene. So we've got a 5, a pent, something, something. We're going to have 2 numbers here. And then we're going to say it's a diene. So how do we number this so that it's the smallest number? Well, you want to number it so that the attached group is also the lowest number. So instead of starting from here, which would be 1, 2, 3, 4, something, we start here, 1, 2, that gives it a 2. Side group. So if we start from here, that's a 1, 4 diene. And that makes this a 2, 1, 2, 3. Propyl. Oh, I left off the penta. Propyl. So 2 propyl. Pent, 1, 4 diene. This is different the way I learned it originally. Originally, they let us put the 1, 4 out here in front of the pent. 1, 4 pentadiene. It flows off the tongue easier, but they thought it led to problems in interpreting the name. So now we're saying this is the 1, 4. The diene is at 1, 4 positions on this penta. So I guess technically it's a better way.
And the purple is from,
This right here. 1, 2, 3.
but you could also count it as 1, 2, 3 from left to right, right?
It doesn't matter in this case because it's attached on its end. It's not attached. If it were attached in the middle like the other one, then it'd be methyl. It'd be methyl ethyl.
No, it wouldn't go to the, it wouldn't go to 4, would it? Because that carbon chain is done. Due to the double bond there.
We can go to
Or
4.
If you went from left to right and counted all
Here?
the way through, yes.
1, 2, 3, 4, 5, 6, 7.
But we're not.
No, we have to include both of the double bonds in the root.
Right.
Right. They have to be included in the root. That's why, and that's the first rule in enes and ines, is you have to include these in the root, even if it's a shorter chain than the overall.
So why is it penton, not pentyl?
Because it's the parent, it's the root. Pentyl is a side group or an
Okay.
attached group.
Okay.
Yeah. That's another quirk. Okay, let's look at the second one. See if we can stump the band with this one. Okay, we got a cyclo. And let's see, where are the double bonds? There's one here and one here. And then we have a methoxy, I think. Yeah. Okay, so to include these 2 double bonds, we need the cyclo hex. And then we have di-ene. So where do we start here? We start so that we can give the attached group the smallest number.
When you start the one right there, the.
If we, let me see, if we started at the one, it would be 1, 2. No, if we started at the one here and went this way, it'd be too big. Went this way, it'd be 1. We can't do that. Okay, here's what I think is the problem. The numbering for the enes is where is the first carbon in the bond, in the double bond. If we started here, and that's the first carbon, then the second carbon has to be there. And that would send us this way and give us two large numbers. So we have to start here, because the second, that defines the first double bond. If we start here, we got to go the other direction. So, okay, I believe that's the reasoning. So that's why we start here and not there. And that makes this 3 and 4. So this would be 1, 3, di-ene. And then on the 2, we have methoxyl. Methoxyl. That's at the 2. 2-methoxyl. Cyclohexyl-1,3-diene.
Can you explain that one more time? Because I don't understand why the one doesn't start with a 2 zone.
Okay,
Because wouldn't it make more sense? Because it'd be, excuse me, a shorter number.
let's do it. See what happens. Okay, if we start here,
Yeah.
then we can't go that direction
Why?
because the ene is numbered by the first carbon of the double bond. If this is the first carbon of the double bond, that one has to be the second.
Oh, so it has to end where it's.
So it has to go that way.
Or
Yeah.
you would have what, like 1 and 7.
If we went this way, then we put the double bond over here.
Okay, that makes sense now.
All right, and the last one is, let's see, we got 7 straights. Okay, the first one is a triple. Then we go over here to another triple. Yep. And we go here to another triple. That's 1, 2, 3, 4, 5, 6. And branch to fluorine, right? Yep. Okay. This one's a triene. One, 2, 3 triple bonds. What position are they at? Well, we want the smallest numbers for the ions. Right, rather than starting from this end, which would give us a 2, 4, 6. We want a 1, 3, 5.
Why won't we start at the end right there and then do that as a subgroup? Like at 1?
Oh, this one?
Yeah.
Oh, because this is a carbon.
Okay.
If we start at this end, then that gives this one a 2,
Okay.
4, 6.
Yeah.
2, 4, 6, right?
Okay.
Okay, so now that we're going like this, that is a heptine. See if they put an A on there. Yeah, they do. They put an A. Heptine. 1,3,5 trione. Okay, so that means this one is at 7, 7 difluoro. Difluoro. It's spelled. There we go. Yep. we're in agreement. Oh, here's a doozy. Might be able to stump the band on this one. Microfibers do a better job. Okay. Two, three, four, five, six, seven, eight. Double bond there, a nitro here. And then we got a double bond here. Yep. And a branch there. Double bond here. Oops. Not an oxygen, it's carbon. That one. Like that. Okay, this is a challenge. We got to include all three of those enes in the parent with the lowest number. So we're going to start here with number 1, 2, 3, 4, 5, 6. So this is a hex something something tri-ene. That's 1. Oh, excuse me. You guys saw that coming, didn't
Yeah, I was gonna ask.
you?
What?
I'm starting on the wrong one. That's 1, 2, 3,
Uh,
4, 5, 6, 7. That's a hept. There we go. So now that's 1, 3, 5. Now for the side groups. All right. We're going to have a, what's that? That's an ethyl. We've got an ethyl at 2. We've got a,
Purple, isn't it?
yeah, 1, 2, 3, propyl at 3. And we've got a nitro at 6. 6. Nitro.
I have a question. So this
Yep.
is where I will get confused with naming, and I would call that a butyl.
Which one?
Instead of 3 purple, I would call that a 3 butyl. Starting with where 3 is, I would count 1, 2, 3, 4.
No, 1, 2, 3. That one's part of the parent chain. You can't name it twice. Right? If you call it butyl, then you're taking a carbon from this one and putting it in that one.
Oh, okay.
Okay.
Yep.
All right. It might help to do this. Once you've decided your chain, then lasso
All right.
the side groups.
All right.
Like that. Okay, now let's see. Alphabetical order. Right, this one comes first, right? That's 2 ethyl. And N comes before P?
Yeah.
6 nitro. And then 3 propyl. After 1, 3, 5, 9. Now let's see. Okay, yeah, we did that right. 2 ethyl, 6 nitro, 3 propyl, hepta. Oh, we don't need that. Hepta 1, 3. Okay.
Explain to me one more time why it's hepto and not hepto, because it's not the parent. Okay.
Right.
Sorry, I just had to talk. Okay. Sorry.
Okay. Yeah. Oh, that's good. That's like Albus Dumbledore. I talked to myself.
Yeah, that's me.
Let's see. He was in the observatory, wasn't he? Thought he was talking to somebody else. He was, but he said, "I talked to myself." All right. Let's see. So just more examples. Oh, combinations. Combinations of enes and ines. Just what you were hoping for. All right. So let's see, 1, 2, 3, 4, 5, 6, and that's a straight chain. So this one's gonna be like that, and like that, and this one with 1, 2, 3, that one. That's it, right? 6. And this one's double. Okay. Now I'm gonna have to read the rules to refresh my memory on this one. Let's see, how do we number this one? Well, we definitely have to include both of these in the name. All right, so the longest parent chain is going to be a hex. But which comes first? The een or the ein? Let's see.
There's a tie.
CC group given equal priority unless there is a tie between the two numbering systems. If there's a tie, it's broken by giving priority to the een. Okay, so if we numbered from the other side, it would be 2 ein. Rather, well, no, this one wins because it's 1 een. Right,
So it's whatever comes first.
it's the lowest number, yeah.
Okay.
So if the double bond were here, then we'd have a 2 een and a 2 ein. And the een would win. But in this case, we don't have to break a tie because it's 1.
Oh, wait, not a tie?
No, it would only be a tie if we did that. Then it'd be 1, 2, or
Oh,
1, 2.
okay, got it.
Put it back the way it was. Okay. So now we need, the first one then is 1 een. And then 1, 2, 3, 4. 4 ein. Yep. That's a mouthful. I'd hate to have to present a paper at a meeting with a bunch of those names in it. Okay, oh, okay. Now what do we do with that second one? I guess there's not a tie. There's still 6. But we do 1, 2, 3, 4. And then this one, and then triple bond on the end. Okay,
You're beginning the double bond. 1, 4.
we want the lowest set of numbers. Is there a tie? Establish the numbering system.
Wait, are we talking about the middle one?
Yeah, the middle one. They're given equal priorities. Oops, sorry.
Wait, but there's not a tie with this one. Because that one is starting that triple bond.
Yeah, because
We're on this-
if we came from this side, it would be 2, 5, which would be a larger number system than 1, 4. Yeah, so 1, 4 wins. So, yeah, go ahead.
So I'm confused as to why it's 4 en, 1 I. Why isn't it 1 I, 4 e? Because wouldn't the en come before the n? Or am I even saying that right?
No, the een comes first,
But why?
convention.
But I thought it would come first because that's where one starts at the.
Well,
or
the-
I.
the lettering comes first because it's alphabetical. It's een,
Oh,
ein
okay.
in the name,
No, I get that now.
but the numbering system gives you the smallest number. In this case, it's 1, 2, 3, 4, not 1, 2, 2, 5. 2,5 would be a bigger number.
I was thinking they had to switch places because the ene came, or what, iron became the ene on the.
Oh, no.
Okay, I understand.
Yeah, it's that alphabetical thing again. Right, so this one would be 4, 1. This would be X. X,
Yeah.
X4, E1, I. Okay, now let's get the cyclone. This is a 7-membered ring? No, 8-membered ring. Oh, it's a stop sign. So we got that one, that one, that one. How to draw a stop sign. This one's a triple. And that one's a double and that one's a double. Okay. So what would give us the lowest numbering system? We do have a single ion, right? And a diene. Yeah. And then it's cyclooctal. Okay, lowest numbering system. We went from this side and went clockwise. Now, yeah, if we went from here, it'd be 1, 4, 6, 1, 4, 6. If we went 1 from here and went that way. It'd be the same if we went that way also. But what if we started with one of these?
Can you try the other one? We have our right answer. Will you try the other, double one
From here,
from the other side, from the one,
from here.
uh,
If we went from here, 1, it'd be 1, 2, 3. That would be the enes. 1, 2, 3, 4, 5, 6. 9. If we did that one clockwise, we'd have to go from this side if we were going to use that one.
what would happen if we went from the other side?
You know what? I think what we have to do is whichever way we choose, the dies have to be together with the smallest numbering system. So we either have to start from here and go that way or start from here and go that way. If we start from here and go this way, we separate the enes in their numbering. But if we go from here and that way, we get both of them together. 1, 2, 3. So that's 1, 3 diene, and that makes, let's see, 1, 2, 3, 4, 5. Yeah, 6, 9.
So you couldn't break them up? Like you couldn't?
I don't think they frown on that one. If you break up the enes, the dienes or the trienes, if you break them up. Let's see. And it doesn't say, does it? I'm just assuming from the way they're naming this, 1, 3, and 6, that is the rule. Wherever you start, you want to keep them together. Like there are 2 of them here, they got to be together. So we'd have to start here and go that way. We couldn't start here and go that way because then they'd be broken up. And that also give us a larger numbering system. Right? If we started from here, that would give us a 3 here. That would give us a 6 there. Okay. That's what I'm taking as the rule, that unspoken rule here. Okay, now we'll go to benzene derivatives. Remember, benzene has that conjugated system. It's actually aromatic. Or we could easily draw it like this. And just rotate the bonds around, right? Those are resonant structures of benzene. Delocalized pi. That's why sometimes instead of doing this, we just do that. Because all the bonds are exactly the same strength, bond strength and bond length. This implies that they're different. This is shorter and this is short. This one's longer, but it's not. Even though we draw it that way, which is perfectly all right, actually. It's just recognize that it's a conjugated system and it's a special kind of conjugate. It's aromatic. Okay. When you have benzene involved, benzene is the root. And we work from the benzene and attach things in those positions. So what's the numbering system? The lowest locator number for each successive substituent. So depending on where they're located, if we only have one, then that's the number one carbon. If we have two, then it depends on where it's located as to the numbering system. If it's across here like that, doesn't matter which way you go. If it's over here, then you would start to go this way. If it's over here, you'd start to go that way. Let's see. So here we have three substituents attached to that benzene. The nitro is here. That's chloro, right? Yep. And then we got a ethyl. Okay. So this is going to be benzene is our root. And our substituents are going to be, what's the least numbering system? We start from here. It's 1, 2, 3, 4. 1, 2, 4. We start from here. It's 1, 2, 3, 4, 5. That won't work. Start from here to be 1, 2, 3, 4. That's still larger. If we start from here and go backwards, it's 1, 2, 5. So
we can't break the end of that one up.
I'm sorry.
But like we couldn't start at NO2, we'd have to start at the other end of the double bond. Like because we couldn't break it up.
Oh, no.
Right.
For the benzene, you don't have to identify where the double bonds are. Because benzene is aromatic. In fact, it'd probably be better if you look at it this way.
Good.
So that you don't, if your eyes aren't drawn away to the enes, right? There are no enes in the benzene, except for the name.
Okay. I should want to write that down.
Yeah.
Benzene and benzene except.
Right, benzene is the 6-membered ring with a conjugated aromatic system. There are no separate double bonds in the benzene. So I think we found the smallest number here. So let's see, ethyl, chloro. Chloro comes first. 1 chloro. And then 4 ethyl. And then 2 nitro. Benzene. Yeah, let's see if. Okay, they numbered it the same way I did. That's good. 1 chloro, 4 ethyl, 2 nitrobenzene. Okay. I'm happy.
And
Yeah.
I'm pretty sure I understand this, but the 4 ethyl is coming before the 2 nitro because of alphabetical reasons, right?
Yes. Yeah, the numbering system is separate from the order in the name.
And it don't tell us when it's a benzene, right? Like we're not just gonna have to automatically assume.
No, it'll be obvious,
Okay.
right? It usually be written like this. with the double bonds in it. I rarely see it like that, which this is proper, but they usually go ahead and just put the double bonds in there, and we just know that that's an aromatic ring.
Okay.
Okay, next. This is a naming convention that's it's older than the current system. But you'll still see it occasionally. It's the ortho-meta-para. Ortho-meta-para. And those prefixes to the name are valid only when there are two attachments to the ring. So if you have two groups here, then you can say they're either ortho to each other, meta to each other, or para to each other. Now, if they're ortho, our first example there, bromine and chlorine. Ortho means you go from this carbon straight to that one. Ortho means straight. You go straight from this one to that one. Right? So it could be on the other side also. Right? All you'd have to do is flip the molecule and you could put it over here. So there's no difference. And the ortho position is always 1, 2. So 1, 2. B comes before C, so we just say 1, 2 like that. Meta is you shift the group down to this position, to the number 3 position. And their example there gives you 2 bromines. Right? So instead of ortho bromochlorobenzene, or O, the first one was O, bromo, and we still are alphabetical, bromochloro benzene. The second one would be meta, would be dibromo. Those are 2 of them. Meta dibromo benzene. And they're in the 1, 3 position. So it doesn't matter which way you go, 1, 2, 3, or 1, 2, 3. Same thing.
Wait, I'm confused on the ortho. Where'd you get the fluoro at?
Oh, I erased it.
Oh, okay. Sorry.
It was previous to this one. Sorry. Now this is meta. Then if we, let's see, they're using nitro in the next case. If we put, let's see, they put nitro, actually they put it on its side, but I'm going to put them down here like this. Works the same. Just rotate it on its side. That's the way they show it. Is a 1, 2, 3, 1, 4. So this is 1, 2, this is 1, 3, and this is 1, 4. So this will be para dinitro benzene.
When we have this on the exam, can we do this like more choice instead of writing it out? Because I don't know if I can write this out, to be honest. Like, I'm being really honest with you. I don't know if I can write this out. I feel like it's gonna be too much for me to
You need to be
get
able
it
to,
out.
you need to be able to write these. Yeah. I mean, for the sake of subsequent chapters that we're getting into. Need practice writing these. There will be some multiple choice, yeah.
So on these, I guess we don't have to put the numbers.
No, when you write it this way, this is what the ortho means. Ortho means 1, 2.
Oh, okay.
How do you know when you're gonna have to write numbers and when you get to use this?
As far as questions on a test go, it'll tell you.
And how will those be worded? Would it be the disubstitute benzenes? Like,
Let's see, do these have a special names and non-numerical system? That would be the key word there. the non-numerical system. These ortho, meta, and para names are what we call trivial. Words, they preceded the current system, but they're still used. Okay. Let's see. The difference between phenyl and benzyl. So there are cases, up to this point, our apparent molecule has been benzene. But there are cases where the benzene or benzene type substituents are attached to something else. And we have to be able to call them something. And we use that YL end ending. The phenylbenzene, benzyl, the phenyl ending is the benzene ring attached directly to something else. So that's why you get that squiggle here. There's something there, probably a carbon. So this is the phenyl something. The benzyl has another carbon intervening. That's the difference. There's no carbon here between this one and its attachment point. Here, there's a carbon between this and its attachment point.
And what are the differences in the names again? A bit,
This-
phenol and benzyl.
This is phenyl substituent, and this is benzyl substituent. Oh, we're also told that sometimes they call it phenyl methyl. Yeah, phenyl methyl. I don't like that. I like benzyl. So are we going to get some examples here? Oh, yeah. All right. Now, my question is, why don't we start with the benzene ring and make the straight chain the substituent?
Well, my question is why is it phenyl not a benzyl? Because there's a carbon group. Is there a carbon attached to it? So I don't understand why it's not a benzyl.
Oh, no, this attachment right here
Yeah,
is directly to the parent chain. There's no carbon in between. Let's see. Maybe it's on the next slide. An example of a benzyl. Oop, no. In order to be a benzyl, let's draw that as an example. Let's see. This would be the way it's written now. That's the phenol form, because it's attached directly to the carbon of that chain. If we drew it as a benzyl, then it would be like this, like that, and then
okay,
like that. There's a carbon in between.
okay. I think I get it now. Yes. Like how it is on the second one.
Oh, yeah, yeah. Right.
Okay,
Yeah. I don't know how I missed that one. So what I'm assuming from the way they're naming this is that the ene takes priority. Even though there's a ring structure, the ene is priority. So we find the longest chain that has the ene in it. And that means that the phenyl becomes a substituent group. That's the only thing that makes sense to me. And sometimes it's written C6H5 just to save room, or pH means phenyl. Large P, small h. What's small p, large h? That's pH, expression of acidity, right? Okay, there's a difference there. Okay, so this would be 1, 2, 3, 4, 5, 6, 7 would be het. And then we start from this end, that would be 2. F2E. I think it's an A there. And then we would attach the phenyl at the 3. 3 phenyl.
So we put the 2 in where the double bond starts, correct?
I'm sorry?
Yeah, I think I'm understanding.
Yeah.
I just gotta talk myself through it. a little
Right,
bit.
the smallest numbering system would put the E
Yeah.
first here.
Wait, I don't understand where the 7 comes in it, the het.
There are 7 carbons in the parent chain. 1, 2, 3, 4, 5, 6, 7.
Oh, okay. See, I guess what I'm thinking is that the phenyl group is part of the parent chain. I guess that's where I'm getting confused because ignore the double bonds. Okay,
Yeah.
that's where I'm getting confused because I'm not ignoring the double bonds.
Oh, yeah.
Because I
Right,
think, because every time I think to include the double bonds, but I keep
Yeah.
forgetting to ignore them. Okay,
right.
that's my problem.
That's true. Right. Now, what would we do? Well, if it wasn't a phenyl group, if it was a diene, a cyclodiene, then we would start with the cyclodiene
Yeah.
and include. And then it would make that other ene a substituent. It gets messy. Okay, benzyl would be a substituent. And then there'd be another benzyl on the other side, right? So we have a dibenzyl. And then we have cyclohexane in the middle.
So the cyclohexane is a parent chain, and then you have 2 subgroups or
Substituents,
substituents. Yeah.
Yep.
To the side.
Correct.
Okay.
Yeah.
So I guess the 1 would start right down there at the lower left,
Sure, that's fine.
and then the 4, I guess, would end up the upper.
Actually, you could do it either way.
So it doesn't matter.
Yeah, because all you have to do is flip it
Okay.
and you'd be back to the same point.
Okay, I understand.
Are you guys good with it
Yeah.
so far?
Yeah.